Hi, this is Alex from devstories.eu. DeepEval Framework, Episode 13 of 18. End-to-end evaluations tell you if a system failed, but they leave you guessing why. Component-level tracing tells you exactly which specific function broke. Today, we are looking at LLM tracing and observability. Consider a standard retrieval-augmented generation pipeline. A user asks a complex question, and your system returns a hallucinated answer 10 seconds later. You need to know exactly what went wrong. Did the embedding retrieval function pull irrelevant documents from your database, or did the final language model generation step just fail to synthesize the right context? You cannot debug this efficiently by just looking at the final output. You need to inspect the internal steps. To do this, you must understand two foundational terms that are frequently mixed up: traces and spans. A trace is the full execution tree of a single operation. It represents the complete timeline from the moment the user sends a prompt to the moment the system delivers the final response. A span, on the other hand, is a specific component or function operating inside that trace. Your entire pipeline execution is one trace. The function that queries the vector database is one span. The function that formats the prompt is another span. The actual call to the large language model is a third span. Every trace is built out of these nested spans. Each span records its own start time, end time, input parameters, and output results. In DeepEval, you capture this hierarchy using the observe decorator. You simply place the word observe with an @ symbol directly above the Python functions you want to monitor. You attach it to your main entry point function, and you attach it to the internal helper functions like your retriever and your generator. When your application runs, the observe decorator automatically intercepts the execution. It logs the exact arguments passed into the function and the exact data returned. It also tracks latency and any errors that occur. More importantly, it understands the execution context. If your main pipeline function calls your retriever function, the decorator automatically registers the retriever as a child span of the main trace. It maps out the parent-child relationships of your functions without you having to manually link them. Here is the key insight. Tracing this way is completely non-intrusive. You do not have to rewrite your application codebase to generate telemetry. You do not need to alter your function signatures to pass trace IDs or context objects down the call stack. You keep your business logic clean and just wrap the components you care about. By doing this, you isolate the data for every individual step. If you want to evaluate just the retrieval logic later, the exact inputs and outputs of that specific span are already locked. You evaluate end-to-end to measure the final user experience, but you trace at the component level to actually locate and fix the underlying code. Thanks for listening. Happy coding, everyone.